So now we'll learn how to calculate the pressure at a point if pressure at another point is known. So we'll measure the pressure with depth, with horizontal, and so on. So the first thing we want to calculate, what will be the relationship between the pressure across a abrupt density change across a surface. As we already know, the surface is defined as whenever there is an abrupt change in density, we define a surface. Meaning this is a physical surface, but the definition according to physics is whenever we encounter a sudden change in density, that wherever that sudden change of density is happening, that is defined as the surface. So this is my surface. So above, let's say there is air, it can be anything also, and below there is some fluid, and the density of fluid is something density rho. We can take that density as rho. So what I do, I take a hypothetical surface. I define a hypothetical surface of cross-section area dA. This is a small hypothetical surface, and we define 2 points, A and B. A is above the surface and B is just below the surface. So let's assume the pressure at A is PA and the pressure at B is defined as PB. So we have defined the pressure at these 2 points. So because of the pressure, as we already know, the pressure is equals to dF upon A. So the force applied due to this point A onto the surface, if we talk about the force will be obviously perpendicular force we are talking about. So F at A perpendicular, and because of B, the force will be applied above. So FB perpendicular. Since we have this PA and PB, and obviously this is my surface, so if I make the FBD of this surface, this surface is not moving anywhere. It's a steady state. If I make the FBD of this surface, the force downward and the force upward, and this surface has a zero thickness, so its mass will be zero, and since its mass is zero, there will not be any mg sort of a thing, and obviously acceleration is also zero. So if you see from this FBD, the FA perpendicular will be equals to FB perpendicular, and this FA perpendicular is nothing but PA multiplied with dA, and that will be equals to PB multiplied with dB. This we are getting from this relationship, pressure is equals to F by A, from that formula. So dA and dA will, it is dA. So if you see, this dA and dA will cancel out, so we will get PA is equals to PB. So this result shows us that whenever we talk about the pressure across the surface, that pressure across the surface will always be constant at equilibrium, because you see acceleration is zero here. So at equilibrium, pressure across the surface will always be zero. So now this result we can use for all calculation purposes. Now we'll learn how to calculate the pressure according to depth, meaning we knew pressure at point A, from there we deducted the pressure at point B. Now we want to calculate the pressure as we go down, perpendicular to the surface.